Alrighty then, it looks like a thing happened late last night. We'll cover it and lots more on today's Daily Space Weather show. Who knew it's a show, folks? Who knew? Oh my God, it's a show. Can you believe it? This is 304 angstroms from the SDO, and that's only a few hours of activity there. We've slowed that down to half the normal speed that we typically show because there was an X-class solar flare. It's a pretty scenic one, too. It had a sort of a long duration there, a couple hours, when that flare was in the M-class portion of the X-ray output range. So that was totally sweet. And don't worry, we've got plenty more imagery of that for you on today's Daily Space Weather. So sit back and relax. We'll handle the solar scenery, as we're known to do. We're not going to spend too much time on this at the moment because this is for our solar flare section. We'll be talking coronal holes. We'll be talking solar cycles. We'll be talking tornadic activity in the northeast when we do the Earth weather portion of the video. So there's that flare in 131 angstroms. Again, slowed down to 15 frames per second. And let's take a look at some other solar features because there are certainly a lot of things going on. The sun, it's a multitasker. So here's the past 24 hours in the first wavelength we showed there. That's 304 angstroms from the SDO, the Solar Dynamics Observatory. And let's add 193 angstroms, since we've got major solar filaments as well. We even named a couple of them last night on Twitter. If you want to name solar filaments after living people, make sure you join us over there. Just follow the hashtag #NameThatFilament. So there's another sweet 24-hour video there. We've added 193 angstroms. That is ionized helium in 304 angstroms and ionized iron in 193 angstroms. Let's take a little closer look here. We've got a crown prominence happening. So if you look up at the polar region there, you see a filament suspended up there, defying gravity via magnetic fields. You can also see a filament there a little bit closer to the equator. Major sunspot group setting in the northwest. The likelihood of additional large solar flares remains in place. We'll show you a magnetic analysis. Before we get to the meteorology segment, there's the equatorial view. Some well-defined coronal holes here rotating in. You can see one of those in the upper left there. Also a series of large magnetically complex sunspots moving in the southeast. There you have some imagery of those. And a quite unstable filament. We've named that one the Alex Lifeson filament. And let's see what else we've got to cover. Well, there's plenty. So there you go. There are the sunspots from yesterday plus today. That is the SDO continuum. And fairly stable here. There is one new sunspot group likely to get a name in the northeast. It might be more obvious in the colorized magnetogram imagery. So there you have that. That new sunspot I'm talking about is right here. When I looked at it in show prep, it was already beta gamma class, and that is a more likely type of sunspot to produce a large solar flare than a plain simple alpha class sunspot group. So let's take a look at some more data here. Let's see what's going on planet Earth. Hopefully you're not too spaced out. This is what's going on planet Earth. We're going to cover volcanoes. So Mayon continues to erupt on the Philippines, on the Philippine island of Luzon. It's producing a 9,000-foot plume of volcanic ash. Flight level 070 over Dacono, Halmahera, Indonesia. That's a 7,000-foot ash plume. 22,000-foot ash plume over central Mexico from Popocatépetl. Sangay exploding, flight level 210. It's a 21,000-foot ash plume. Cotopaxi exploding, flight level 200 in Ecuador. It's a 20,000-foot ash plume. 22,000-foot ash plume over Sabancaya in Peru. Ubinas exploding, flight level 200 over Ubinas in Peru. 20,000-foot ash plume. And Pitan de la Fournaise on the Isle of Réunion has had increasing activity some lava flows in the southeast slope, etc. Let's see what's going on for earthquakes there are the past 90 days. We do have quite a few quakes around the Pacific Rim. Keep in mind, folks, any earthquake can be a foreshock. It's perhaps the best statistical way to forecast an earthquake is where the last earthquakes have happened. Foreshocks, they are able to forecast earthquakes. So let's talk about the ones that are of a 5 magnitude or higher. So there was a 5.2 in Indonesia. That was at 1813 Universal Time yesterday evening. 5.2 at Indonesia. And then at 1931, just about an hour later, a 5.2 at the Kermadec Islands there, north of New Zealand. A bunch of quakes there south of Alaska, by the way. Those are not of a 5 or larger magnitude. Papua, Indonesia had a 5.4. That was at 2:51 this morning. Again, quite a few quakes around the Pacific Rim there. Last but not least, a 5.3 struck the Loyalty Islands region. That was at 11:26 this morning. And let's get back to space. Nice. So here is 304 plus 171 angstroms. And that is another 24-hour SDO video. And let's get to some more solar features. The 10.7 centimeter radial flux is now up to 170 solar flux units. There's the 1-year graph of the solar cycle 25. And you can see this upward trend happening here, both in the troughs and the peaks of both the black line and the red line. And we're expecting that red line to come way up here. It looks like Solon.info might be a couple days behind there. The sunspot number is actually at, I think it's at 183 at the moment. So anyway, that's neither here nor there. Again, there are so many features to cover. Let's look at the Space Weather Enthusiast dashboard next. No solar storms forecasted. No geomagnetic storms, geomagnetic unrest, CME impacts, coronal hole impacts, etc. Things are calm. Next, we'll show you Earth's magnetic moment from space for the past 4 hours. Solar wind here pretty nominal. Nothing major going on with that. We show it daily anyway, just to remind people that Earth's magnetosphere is not evaporating. The likelihood of a pole shift, of a magnetic pole flip, is extremely statistically low. We're not convinced about any of that nonsense. Here are the past 4 hours of Earth's magnetic moment from the ground. And if Earth's poles were flipping, we'd see all kinds of evidence in all of the space weather data. Everything from the electron flux, the total electron content, to the magnetograms. All of the features would start to look all funky. They don't, because Earth's magnetic poles are just fine. That's the past 4 hours of Earth's magnetic moment from the ground. It's great at showing geomagnetic storms when they happen, but they ain't happening at the moment. KP index currently at 1.33. It's a KP 1.33. The planetary K index is a global average of geomagnetism. And again, things are geomagnetically calm. Let's move to the real-time solar wind next. Current conditions are about 400 kilometers per second for the solar wind speed. Solar wind density 3.3 protons per cubic centimeter. That is a pretty diffuse solar wind, and as far as the speed goes, that is quite average and unremarkable. Moving on to the GOES magnetometers, they're pretty smooth as well. No major space weather events going on at the moment. Let's take a look at what's going on in the heliospheric current sheet. So this is perhaps the best piece of predictive data that there is as far as forecasting things like new sunspots. Earth is still in a North Pole-oriented current sheet, and I'm seeing some delay happening here. So I'm expecting a new sunspot to rise or form in the southeastern limb. These forecasts are very rarely incorrect, and it has to do with understanding how this data correlates with reality. Data correlating with reality is what we call actual science, not idiotic conjecture about how these things work. So let's bring up the latest image here, and we are still waiting once again for this magnetism to leave the north heliographic pole. That coronal hole must leave and migrate all the way to the opposite side of the sun. It'll happen. We'll be showing you it happen throughout the cycle. Next, our line of sight field plot. Here the sun's B field is depicted in blue, north polar field in green, south in red. It also shows the gong magnetogram, the grayscale portion. Lots of organized magnetism in the photosphere at the moment on the Earth-facing side of the solar disk. It's exciting stuff. And here's our line of sight coronal hole plot. The coronal holes that we currently have on the Earth-facing portion of the disk are North Pole oriented. So let's take a look at those next. Here is our SDO 211 angstroms wavelength. So we may be in store for some significant incoming solar wind here in about 5 days. Because this is a very large and very well-defined coronal hole. We've also got one down here. And if you're not familiar with coronal holes, they are the source of high-speed solar wind. So these things are like low-pressure zones on the sun. And the thing about low-pressure zones on stars, folks, is that those low pressures are so low that they blast material out into space. So these create the Parker spiral, the solar plasma that we know as the high-speed wind. Coronal holes weren't discovered until the 1970s because they can't be seen from the ground level. They must be viewed in specific wavelengths. And yeah, those are pretty well defined and pretty large. They are of North Pole orientation. And let's move to sunspots. So like I said earlier, we will have one new named sunspot group likely up here in the northeast. That will be 3361. It is already beta gamma class. And let's take a look at the formation of that in our SDO continuum. So there's the SDO continuum. That is another 24-hour video. And behind that larger alpha class sunspot, oh, we've got another new group that'll likely get a name as well. So that one formed pretty rapidly there. Oh yeah, make it 3 new named sunspot groups. One here. One just formed down here quickly. And there's also one up here. So 3 new named sunspot groups. Expect the sunspot number to rise again in the next 24 hours. Keep in mind when this group sets, the sunspot number will rapidly drop, but that is still on the Earth-facing portion of the solar disk. So at the moment, we're going to be pushing 200 sunspots once again. That is some serious solar activity. So let's move on next to talk about energetic particles and solar flares and all of those exciting things. Goes proton flux here. No spikes, despite an X-class solar flare. And there is the X-ray flux for the previous day. So the peak flux of that X flare was around 2315 universal time. And it was only an X1 class flare. Since then, there has been an M class flare. It was an M1.27 just before 7 o'clock universal time this morning. We usually show the 3-day chart, so there is the 3-day chart. And let's take a look at our flare wavelengths. So here we've put together the 131 plus 171 angstroms wavelengths. Those are both species of ionized iron, and that is some sweet imagery indeed, folks. Here we've swapped out the 171 angstroms for 94 angstroms. These are 24-hour videos, and strap on your seatbelts because here comes some incredible close-ups. So here is just the flare. That is that's from 2200 yesterday evening until 2:30 this morning at 15 frames per second. The previous video was 30 frames per second, so only a few hours there. It was a long duration flare indeed. So it spent a couple of hours there in the M class range. Let's take a look at it in ionized carbon. That's pretty sweet, right? Wait for it. You're going to see a lot of white appearing up there in the upper right. And there it goes. A lot of carbon there showing up rapidly, right around the same moment as the flare occurred. What's up with that? Is it controversial to show the carbon? I don't know. Facts. Facts are very controversial, folks. It is the year 2023, after all. So the 1600 angstroms wavelength shows ionized carbon. And we'll let that play through one more time. And hopefully showing an SDO video is not too controversial that it'll get the video demonetized. Let us know in the comments what you think. There's all that carbon showing up. The result of nuclear fusion occurring around the moment of that X-class solar flare. Here we've added 171 angstroms, where you'll be able to see a bunch of plasma looping around there. And these wavelengths are all portions of the extreme ultraviolet light spectrum. Of course, the sun emits all kinds of different frequencies. These are very specific frequencies. Again, 1600 angstroms is ionized carbon. 171 angstroms are the spectra of ionized iron. Here we've put 193 plus 335 angstroms. Those are both species of ionized iron. Keep in mind, folks, because iron is a massive element, it has a lot of electron shells. And so there are many different states of ionized iron that are covered by the SDO. 171, 131, 94, 211, 193, 335, those are all ionized iron. Different numbers of electrons in their shells. Next, here's 131 plus 94 angstroms. These are the optimal wavelengths to view solar flares. They take more images per minute than the other wavelengths. These are the flare wavelengths that you'll see all over the internet all day today for everybody covering space weather. They'll be showing you images in 131 plus 94 angstroms. You'll see it on the thumbnails. You'll see it on people's videos. And you'll see people wondering, making up all kinds of nonsense about what's going on there because, well, first of all, there is no coronal mass ejection associated with it, so a great reason to not conflate flares and CMEs. We'll get to that in a minute as well. There's 94 angstroms by itself. And we'll also show 131 angstroms by itself. Again, these are only a few hours of activity at 15 frames per second. Our 24-hour videos are typically at 30 frames per second. How you like them apples? Are you enjoying the Smash News Network Least Busted Name and News? Well, we're enjoying your viewership. So here comes some more. This is a 24-hour video in 131 plus 94 angstroms. We've sped that back up to 30 frames per second. And that is a very well-defined coronal hole in the northeast. They're not usually so visible in these wavelengths. That one is. And don't worry, we've got plenty more, starting with a star chart. So this is what's going on over Lehigh Valley, Pennsylvania at the moment. We like to show it daily because, well, some astrologers watch our content. So that's what's going on at the moment. And highly recommend you check out the night sky, because right after sunset, you'll see a great view of Mars and Venus very close together, and then just a little bit after that, the full moon will rise. So it's a great night to be viewing the evening sky there. And of course, Venus and Mars are bright enough that even with the full moon, you'll still be able to see them. Here is your solar system forecast. That's where things are today. And we'll advance this 1 week. Full moon tomorrow night. Well, I mean tonight, really. Here's where things will be in a week. And we'll be moving to last quarter. At that point, we'll be moving to a gibbous waning moon. Let's take a look at coronagraphs next. So here are the coronagraphs. Okay. These are coronagraphs from yesterday. Again, coronal mass ejection activity here, kind of light, especially considering that there's been an X-class solar flare. And let's see if we're just missing it because it happened so close to midnight. And nope. A prime example of how solar flares are not the same thing as coronal mass ejections. Completely separate phenomenon. They are associated. However, don't conflate the two. They are very, very different things. So solar flares are X-rays, and coronal mass ejections are protons. So one is photons, one is protons. They're completely different. We regularly see solar flares without coronal mass ejections, and we regularly see coronal mass ejections without solar flares. They are a separate phenomenon. Please don't conflate the two. It's embarrassing. We hear it constantly, especially on channels that have no idea what they are talking about when it comes to space weather. So being an authority on a thing takes a lot of time, folks. I mean, I've been studying cosmology since the 1970s. I am not a noob to this game. And so there are your coronagraphs. Again, it's quite chill as far as CMEs here. Let's take a look at stereo A as well, just to provide some additional contrast. There's some more data for you. Stereo A located over here on the left. Soho Lasco C3 on the right. You can see Mercury there on both coronagraphs. And let's cut to our custom coronagraphs, because we show them daily on the channel. So here's the past 24 hours showing SDO 193 angstroms plus Lasco C2 and C3. There you have those. We'll zoom in a little bit closer. You can see at that flare moment, nothing doing as far as coronal mass ejections. And many of us believe that the plasma motions are causing the flares, not the flares causing the coronal mass ejections. Cause and effect are super important in physics, folks. If you've got them backwards just because they correlate, that's a problem. Anyway, those of us interested in the actual physics are interested in the way things actually work, not alarmist nonsense about just utter nonsense. So let's move to filaments, because, yeah, we've got some major filaments here. And let's show them to our pals, those folks viewing the videos. So we've named these filaments already, at least two of them. This one down here is the Bella Fleck filament. If you're not familiar with the banjo player Bella Fleck, check it out. And this one over here is the Alex Lifeson filament. Now this one over here, which might be associated with that X-class flare, I don't think it is. That's actually the Getty Lee filament. So anyway, again, if you want to name filaments, make sure you join us over on Twitter to name filaments after living people. It's fun times. Just kidding. Twitter is a complete headache. We are on there for business purposes, and if you think the censorship is fixed, please enter into the real world. Apple, Alphabet, Meta, and Twitter continue to censor you on the internet. Yes, shadow bans are censorship, because limiting people's reach is not how social media is supposed to work. That's how corporate media works. by controlling the narrative. Here are the past couple of hours from the GOES 18 SUVI showing ionized helium, 304 angstroms. And that, my friends, brings us to the bonus features segment. First on bonus features is the satellite's community dashboard, checking for charging hazards. And at the moment, we ain't got none. We don't have any. It is smooth sailing for satellites. Next, the GOES electron flux. That is measured using radiography by the GOES 16 and GOES 18 from their geosynchronous near equatorial orbits. They measure it at the F layer of the ionosphere, which is located at about 300 kilometers of altitude, and back into warning levels here. So high levels of electron flux continuing. Surprisingly high levels, actually. And let's take a look at the 1-year graph. That should put it in context for you. A little electron storm there. Nothing very major, just a little higher electron contents than perhaps expected. In fact, this is the longest period of this level of electron flux, I think, in the past year, the amount of time depicted on that graph. So here's a forecast model. NOAA forecasting pretty flat, pretty similar levels here moving forward, and then a slow decline. No argument from me there. And let's take a look at the layer where it is measured, the F layer of the ionosphere. Feel free to pause the video on this frame if you're not familiar with the distances in kilometers depicted. Electromagnetic radiation, penetration, layers of the atmosphere, temperature inversions, etc. So here's the F layer of the ionosphere. Its vibrational frequency. And things are looking pretty smooth here. Of course, you're seeing the highest frequency there under the northern hemisphere at noontime, because that is a pressure exerted by incoming solar radiation. Nothing too special happening there in the ionosphere. Things are looking very normal in the F layer. And don't worry if you're not familiar with this imagery. If it looks like Greek or perhaps Cyrillic, here is the anomaly from 30-day median. This will show you high-frequency anomalies in blue, low-frequency anomalies in red. Again, things are looking pretty normal in the ionosphere. Nothing to write home about there. We do show these data runs daily on the channel because you never know when this will become useful in the future. Anyway, there is the latest image, 12 o'clock universal time ionogram and 12 o'clock universal time anomalygram. We also show total electron content daily on the daily space weather videos, and feel free to pause the video on this frame if you're not familiar with those distances in miles. Here is the total electron content forecast depicting the free electrons from the altitude of your GPS satellite down to your handset level. We are seeing continued anomalies in the southern hemisphere there. Places like the southern Indian Ocean, the Southern Ocean, and around Antarctica. A little bit disorganized there. And again, if Earth's poles were flipping, these would be all in weird places. They aren't. Here is the North American total electron content anomaly from the 10-day average. Keep in mind this depicts high electron contents in red and low electron contents in blue. It's literally a count of free electrons, again, to about 12,500 miles of altitude. We'll also show the latest intensity gram and the latest colorized magnetogram. So this sunspot here, the one that is associated with that X-class flare, it still does show significant magnetic shear. It is still beta gamma delta class, the most likely type of sunspot to produce a large flare. This one here is beta gamma delta class as well, and it's moving right to the Earth's strike zone. Here are some more, and these are also magnetically complex sunspots. And there are some new ones just rising and forming in the east. So sunspot number going to rise again today. We'll have 3 new named sunspot groups likely. So there's one, that's beta gamma class. That one there, Looks like it shrunk a little bit. That could still get a name if it sticks around. That one there is new. So, yeah. So, some significant new sunspots showing up there in the east. And to our regular viewers, that's probably no surprise. Let's move to our meteorology segment. Because, hey, we don't just do space weather. We do Earth weather as well to provide a value-added service here at the Smash News Network, least busted name in news. So what we're looking at here is sea surface temperature anomaly and currents. The color gradation is the sea surface temperature anomaly, and the animation is the currents, the ocean currents. So, and by the way, look at how warm the water is around places like Ireland and Iceland. Also around Norway. The water's pretty warm, folks, and the Gulf Stream is still making it to Europe. And the Northern Hemisphere is still not entering an ice age or a snowball Earth scenario. Because technically, folks, an ice age is when a planet has ice at both poles throughout the year, which means you've been in an ice age for your whole life. Anyway, look at the equatorially warm water there around the Pacific Ocean. We'll show the whole planet. There is the largest body of water on planet Earth. It's also the world's largest surface heat sink. Yeah, water. It has a very high latency of heat. That's why it's used for water heaters. Yeah, the main feature of the water heater is the water itself in the water heater, because it retains heat for an extended period of time. Anyway, these are the sea surface temperature anomalies for the Southern Ocean. Sea surface temperature anomalies for the Indian Ocean. Again, also currents depicted here. There is the Atlantic, not to be confused with the propagandistic publication, The Atlantic. That's an ocean. That's reality. The Atlantic prints a bunch of crap and nonsense. And here is the Arctic Ocean. So that's what's going on there. A lot of cold water here, anomalously cold water, even for winter time around Australia. Anyway, here are the jet streams of this side of the planet. A huge anticyclone here, just south of the equator. You can see this counterclockwise rotation. That makes it a high pressure zone. A huge high pressure zone here. South of the equator there, northwest of Australia. Here are the surface winds of this side of the planet. Surface winds of the west. How about the jet streams? Still fairly coherent jet streams over the U.S. at the moment. Jet streams over Europe and Africa and the Middle East. And last but not least, surface winds. So that's what's going on. Next, our drought map. And droughts have subsided a little bit in the central part of the country. We do still have some significant droughts in extreme drought conditions, actually in Florida, Louisiana, Texas, Michigan, Iowa, Oregon, and Washington. So that drought map, you can view that yourself if you like on windy.com. That is the drought intensity map. And let's take a look at what's going on for clouds and fog over the Americas. So that's clouds and fog. It's still dark over half that map. That's why we're using the 3.9 micrometer infrared radiation map. Quite a lot of clouds there stretching all the way from Texas to Newfoundland. Huge cloud band there. By the way, funnel clouds were reported in the Lehigh Valley. Yeah, we had a tornado warning for the Allentown area, and there was a funnel cloud reported in Lenhartsville. So that is west of the Lehigh Valley, I guess. I think that's actually the Schuylkill Valley, but there were tornado warnings in Lehigh and Berks counties. And we got some imagery of the aftermath there. Saw some incredibly towering clouds. Funnel cloud reported about 2 miles west of Lenhartsville there. So a bunch of warning locations there. That is from The Morning Call. And we did get some aftermath imagery. If you want to view that, view the Instagram page. We are all over the internet at Smash-O-Mash. So join us on social media That's your official invite. Here is your weather.gov map, and we're showing the key here briefly to show the weather warnings. Weather.gov is where to get your weather warnings. Blizzard warning there for Denali, Alaska, it looks like. And here come some forecasts. So there's the forecast of temperature anomaly for the next 72 hours. 72-hour GFS temperature anomaly forecast in degrees Celsius. A cold pocket will occupy the north-central U.S. Hot pockets are not good dietary products. And hot pockets occupying especially the Pacific Northwest and the Northeast. So some anomalously warm temperatures coming. Again, it's a 72-hour GFS temperature anomaly forecast in degrees Celsius. Here is the GFS 250 millibar wind speed forecast. That is the forecast for the jet streams, which we told you yesterday they're going to get a little incoherent over the U.S. They'll come back here in the next 3 days. Last but not least, we'll show pressure and precipitation for the same model and the same time period. The GFS 72-hour pressure and precipitation forecast. Moving right along to our lightning mapper. So that's the past about 10 hours, and we had just a series of bangers last night striking the Lehigh Valley area. Since then, things have calmed down. I think there may be more coming this afternoon. And here's your current lightning map from lightningmaps.org. So that's where the current cells are. It looks like we've got some terrestrial strikes while we were recording the video. There's one south of Huntsville, right near Decatur. Also some minor activity there in South Dakota and Oklahoma. By the way, if you enjoy the content, press like, subscribe, share, etc. Also, visit our links. We've got a whole series of links. We created a massive web ring for people like you to join us all over the internet. You can also support the channel via the Amazon and Hemp Lucid shops, also Patreon, and we do have our own subscription services site as well. So visit the links at smashomash.com. Help us out that way. Share the content, press comment, all of those sorts of things that people do. And you can support the channel by picking up some merch as well. So today's featured product is the bestseller on the merch shop. Links to that on the homepage as well, the Smasho merch shop there on Redbubble. The Do Not Pole Vault the Caldera design does feature our homepage, smashomash.com, and the URL for the YouTube page. Because, well, the channel's been creating the most comprehensive space weather and detailed imagery of the sun for like 6 years now. So congratulations on realizing it exists. Go tell your friends and foes about it, perhaps with some themed merch. And whatever you do, do not pole vault the caldera. Why? Because our finest days lie ahead, folks. Our finest days lie ahead. So don't be fatalistic. The world is not ending. It's just ridiculous to suggest it is. And remember, the oldest grift of all time is perhaps, the end is near. The end is near. Make sure you send me a bunch of cash, because I'll save you from yourself, folks. I'll save you from yourself. And remember also that all cults believe nonsense. It's a requirement. Whether it was Nazis or the Branch Davidians or whether it was Heaven's Gate, they all believe nonsense. It is a crucial feature of all cults. You can also join us on the Smash Team site if you want to support the channel via subscription services. The official subscription services site of the Smash News Network, Least Busted Name in News, is smashomash.com/Smash Team. We built our own site to replace Patreon because, well, ours is better. We saw the writing on the wall, and sometimes if you're a true visionary, you got to be so far ahead of the curve that people go, "What's he talking about?" Because somebody's got to snap people into reality. And that is what we're doing at the Smash News Network, Least Busted Name in News. So thanks for tuning in. We're going to close out the video with the latest Doppler radar. We'll also show clouds and fog. Again, it's a 3.9 micrometer infrared radiation map. If you want to see clouds and fog at nighttime, use the NASA GOES Interactive Weather Satellite Suite. 3.9 micrometers shows clouds and fog even when they're not visible to the visible satellite because, well, visible satellites require light to see clouds. Last but not least, there is the water vapor map. We've got some stagnant air over Colorado. Maybe people aren't in Colorado. It looks like there's not a whole lot of hot air coming out of the state. Colorado, the hot air capital of the U.S. Anyway, here's where we'll close things out with a recap. U.S. Doppler radar map. Clouds and fog. And there is your water vapor map, which should clear things up. Hopefully we've cleared things up when it comes to space weather and all kinds of other facts, which of course are now controversial. So since people like controversial stuff, make sure you press the share button, like, subscribe, comment, etc. And in the meantime, I'm going to head back to the bunker because I've been spooked from watching nonsense on YouTube. While I'm gone, may that solar wind be at your back. Back to the bunker. Whoa!